Hi, I'm Jelena Lowe. This is the presentation for Assessment 1, User Experience and Wearable Research. Severe workplace injuries that relate to strains and sprains are usually caused by lifting, pushing, and carrying large and heavy objects. There have been many ways to prevent these accidents occurring, but still the best way is self-correct your posture whilst carrying out work. That means ensuring your back is vertically straight and tall, keeping the shoulders back, not bending your neck, by keeping your head level, not slouching, and so on. Lately, there have been some digital wearable devices on the market, which detect and alert the user of their bad posture, motivating them to self-correct it. This builds the muscle memory and create habit to prevent bad posture long term. My aim with the group is to look at designing a digital wearable for posture correction. I shall be focusing on two areas of research, aesthetics and sustainability. I use the hot air balloon retrospective as my research method. Step 1. The wind represents all the external forces that can have an impact on the course of our hot air balloon, both threats and opportunities. They can be legislative, social, and technological changes that we don't have any control over. For aesthetics, these forces are the emotional and social comfort that influences the social wearability that the user decides to adopt and reject the wearable system. For sustainability, the external forces are the social and environmentally responsible associated with the materials manufacturing process and distribution method. Step 2 is sandbags are the internal challenges designers face and the weaknesses that literally dragging us down. This is balanced with step 3 on the other side, which is hot air, and represents all the strengths within the organization in the wearable product and anything that we have control over and gain a competitive advantage. For aesthetics, a wearable has to conform to the norms associated with the fashion of clothes and accessories that make up how we dress up. For sustainability, it is reducing the wastage and cutting fabric. An example is Unspun, an innovative denim company that make completely custom-fit jeans to eliminate waste and avoid using large minimum quantities to make the price of one jean feel affordable. Step 4 are the passengers, who are all internal stakeholders that have the influence on the direction of the hot air balloon, which is our project. These people are the fashion designers who can demonstrate the wearable being worn, the manufacturers and suppliers, waste recycling companies, and the investors. Step 5 are the observers, who are all the target audiences and users of the wearable that we are aiming to serve, as well as the external stakeholders that have staked on interest in the journey. These are the workers who will use the wearable product to correct their posture. Also, health professionals and workplace health and safety officers who are always interested in improving the health and well-being of humans. Step 6 is Paradise Island, the end of our journey. This is the dream destination and goal that we are working towards in the 5 to 10 year time frame. How does the future look like in our imagination? For our wearable, we are aiming it to be used by office and warehouse workers. The wearable is visually aesthetic and ergonomically comfortable. The wearable can be made in the sustainable way and it contributes to the circular economy. Lastly, step 7 is the direction of the hot air balloon. The steps to take towards Paradise Island. Everything that we're aware of today, which can do to reach our destination. This is the research into aesthetic designs and look into sustainable practices. Then design and prototyping will use the Arduino kit. It may take several interactions to make something viable. Next is the objectives, methodology, and findings, and come up with a set of design considerations. For the aesthetic consideration, my objectives were to look at what influences a user's decision to adopt and reject a digital wearable for posture correction. Also, I am looking for some sort of scale of measurement to test our aesthetic factors. A methodology is literature search on Google Scholar and blogs of fashion designers using digital wearables in their designs, such as smart clothing. The findings I found was the definition of aesthetics to use as a measurement akin to other performance measurements on the wearable that lead to positive users' experience. This highlights that aesthetic is very much an influential factor, and a user may adopt and reject a wearable product. Also, I found a wearability acceptability range scale called WEAR, which is a useful tool to helping to identify the social acceptability of a wearable device, including its aesthetics. A list of designs consideration in the area of aesthetic becomes the product must offer options for personalization so that everyone is not wearing the same thing. The product should have the aesthetic pleasing appearance, and the product must not be considered disfiguring to its wearer. Here I found some digital posture correction wearable devices as examples. The Upright Go 2, the U Posture, the Alex N5, the 8 Sense, and the experimental device worn like a body harness for spinal cord patients. Next are the sustainability considerations. My objectives here is to trial out wearable for sustainability. Methodology again consists of literature search on Google Scholar and looking at the outcomes from the COP26 summit and climate change held in Glasgow in November last year. My findings are that we should be looking at the whole project lifecycle to achieve better sustainability. This is called the cradle-to-cradle principle, as opposed to cradle-to-grave. Cradle-to-cradle is looking at the life cycle and demonstrate care about the environment and human well-being to producing products that can be disassembled and integrated into new products of being disposed. We should reuse what you can, recycle what cannot be reused, repair what is broken, and remanufacture what cannot be repaired. In the COP26 summit, a pact was made to accelerate action on climate change and commit to limit the rise of global temperatures to 1.5 degrees Celsius. All countries commit to reducing greenhouse gas emissions by 2030. This means stop using fossil fuels such as coal, oil, and gas, and recarbonizing road transport by turning to zero-emission vehicles. Finally, my set of design consideration in the area of sustainability are the product must use natural and sustainable materials, not synthetic. The product must be able to be reused or easy to disassemble for recycling. The product should use custom design manufacture that is at least as cheap as mass producing it. The product must not be bulky and heavy batteries. Here are my references. Thank you for listening to my presentation.